guys, today's lesson is on factoring quadratic equations. This is the second way we're going to learn how to solve quadratic equations. The first way was graphing, and today we're going to review 4 different ways of factoring. The first way we're going to talk about is factoring out a greatest common factor. That is when there's a greatest common factor or something in common between the terms of the equation. What we're going to do is to divide each term by the GCF to factor the equation and then set the factors equal to 0 to solve for our solutions. What is common between these two terms in number 1? That would be x. So our GCF is going to be x. And factored form is going to be the GCF times whatever's left after you divide both terms by x. Factoring is writing a multiplication problem. So the question is, what times what is x squared plus 5x? Our answer is going to be x times x squared divided by x is x. 5x divided by x is 5 equals to 0. This equation I wrote here in the pink is the factored form equation for number 1. Writing an equation in factored form helps us to solve it, since one factor times another factor is equal to 0. We could say that x is equal to 0, or x plus 5 would be equal to 0 in order for that statement to be true. The last step is to then solve those two equations. The first one giving us 0. And the second one, if I wanted to solve for x, I would subtract 5 on both sides to get negative 5. Notice I'm writing this in a solution set because 0 and negative 5 are solutions to the equation above. If we were to substitute 0 into x squared plus 5x equals 0, it would solve the equation, or we would get a true statement. Same goes for negative 5. If I were to plug it into our original equation, we would see it's a solution to the equation because the left side would equal the right side. Let's take a look at number 3. What is common between these two terms? What is the biggest number, the greatest common factor that goes into both of those terms? Well, the biggest number that goes into 4 and 8 would be 4. And what else do they have in common is the x. So our GCF is 4x, and I'm going to start writing our equation in factored form. To find the next factor, we're going to divide both of the terms by that GCF, and we'll have 4x times the resulting expression. 4x squared divided by 4x is x, plus 8x divided by 4x is 2 equals to 0. Now that we have the factored form equation, or the factored form equation for the original equation, we know that this times this is equal to 0. To make that equation or expression true, one of the terms must be equal to 0 for the left side to equal to 0. So we could solve for x by setting both of the factors equal to 0 and then solving the two equations. In the first equation, we would divide 4 on both sides to get x is 0. And in the second equation, we would subtract 2 on both sides to get x is negative 2. The equation above has 2 solutions. What I'm going to ask you guys to do is now try number 2 and 4 on your own. Pause the video. Once you get your answers, play the video to check. Here are your answers for 2 and 4 in the GCF, or greatest common factor section. In number 2, the GCF was 5x. That's the biggest number that goes into 5 and negative 30. And in addition, both of those terms have an x in it. So our factored form would be 5x times the resulting expression after you divide both terms by the GCF. 5x squared divided by 5x is x. Negative 30x divided by 5 is negative 6, in which the second factor would be x minus 6. We're going to set the factors equal to 0 and solve to get our answers of 0 and 6. Lastly, number 4, the GCF of those two terms is 9x. When you start writing your factored form of the equation, the 9x is out in front, times the resulting expression after you divide. 9x squared divided by 9x is x, and negative 18x divided by 9x is negative 2. Set both factors equal to 0 and solve the equations to get our answers 0 and 2. The second type of factoring is when there is no GCF. It's called the difference of squares, and when there are two terms. Specifically, these two terms are using the subtraction operation. It's a difference of two terms being squared. Over on the right side is the rule for the difference of squares, which says if you could write the expression as the difference or subtraction of two terms being squared, then this would be the factors. The first term being squared plus the second term being squared times the first thing being squared minus the second thing being squared. Remember, factoring is asking you to write the expression as a multiplication problem. So they're asking us, what times what is x squared minus 64? Well, the first thing we should always check to see is if there's a GCF. There is nothing in common in those two terms. Therefore, we'll check if we could write it as a difference of two terms being squared. It is already a difference of two terms. However, both of them are not being squared. The first term, x squared, could be written as x in parentheses squared. This first term is being squared minus, think about how we could write the number 64 as a number squared. What number times itself as 64? That would be 8. Since we can write this equation as a difference of two terms being squared, our resulting factors would be x plus 8 times x minus 8 equals 0. This is the factored form for the equation in number 1. Just like in the first section, now that it's in factored form, we're going to set our factors, those are the expressions being multiplied to each other, equal to 0, and solve both of these equations to find what x is. In our first equation, we'll subtract 8 on both sides to get x is negative 8, and in the second equation, we'll add 8 on both sides to get x is positive 8. We have two solutions for our equation in number 1, and that would be the values negative 8 and 8. Let's take a look at problem number 3. Again, we have two terms with no greatest common factor. There's nothing in common with those two terms. There's no number that goes into both 4 and 9. The next option for an equation with two terms is to check to see if it's a difference of two terms being squared. It is a difference. Let's see if we could write it as the difference of two terms being squared. As you can see, this first term, 4x squared, only the x is being squared. We want the entire term to be an expression times itself is 4x squared. So the question is, what times itself is 4x squared? Or what times itself is 4? That would be 2. And what times itself would be x squared? That would be x. We could rewrite the first term 4x squared as 2x squared. And can we think of a number, that one being multiplied by itself is 9? Yes, we can. That would be 3. This expression or equation can be written as a difference of two terms being squared. Therefore, the factors are 2x plus 3 times 2x minus 3. Now that we have our equation in factored form, meaning it's written as a multiplication problem, we could set the two factors equal to 0 in order to solve for x. We write our answers in a solution set. If we solve the first equation, we would subtract 3 and then divide the 2 to get our solution negative 3 halves or negative 1 1/2. And the equation to the right, we would add the 3 and divide the 2 to get our second solution of 3/2. What I'm going to ask you to do is try number 2 and 4 on your own. Pause the video. Once you get the answers, play the video back for the solutions. Here are our answers for number 2 and 4 in the difference of squares section. Number 2, we could rewrite this expression as a difference of two terms being squared, being x squared minus 9 squared. Therefore, our factors will be x plus 9 and x minus 9. Next step would be setting the factors equal to 0 and solving for our x values or our solutions, which would be -9 and 9. Number 4 can be rewritten as a difference of two terms being squared using 6x and 5. 6x times itself is 36x squared, and 5 times itself is 25. We would then write our two factors, which would be 6x plus 5 and 6x minus 5, and set them equal to 0 to solve. Our solutions would be -5/6 and +5/6. The next section of type of factoring is when we have no GCF and we're left with a trinomial, specifically when a is 1. In order to factor this equation or to write it as a multiplication problem, you're going to look for the product of C and the sum of B. Those are the two values you would use in your two factors. You want to find two numbers that have a product of C and a sum of B. So in problem number 1, we need two numbers that multiply to get 4 and add to get B, which is 5. What two numbers multiply to get 4? Well, we have 2 times 2 is equal to 4. However, does 2 plus 2 equal 5? No, it doesn't. How about 4 times 1? That also equals 4. Does 4 plus 1 equal 5? Yes, it does. Therefore, those are the two values we use in our factored form. The two factors will be x plus 4 times x plus 1. A really quick way to check to see if your factors are correct is to FOIL or multiply these terms out. For example, we would multiply x times x is x squared, x times 1 is x, 4 times x is 4x, and 4 times 1 is 4. When you combine the like terms, we would get x squared plus 5x plus 4, which is exactly what we started with. So therefore, we know that our two factors are correct. X plus 4 times x plus 1 does equal x squared plus 5x plus 4. So I'll rewrite x plus 4 times x plus 1 equals 0. Now that it's in factored form, we'll set the two factors, those are the expressions being multiplied to each other, equal to 0, and solve. For the first equation, we'll subtract 4 on both sides to get -4, and the second, we'll subtract 1 on both sides to get -1. Problem number 3, again, we have a trinomial. There's 3 terms in this quadratic equation, and there's no greatest common factor that goes into all those 3 terms. There's nothing in common with those 3. Since it's a trinomial, when a is 1, we're going to use the same method as problem number 1. We're going to find two numbers that have a product of 28 and a sum of -11. Multiplies to get 28 and adds to get 11. Let's go through some factors of 28 to see which ones would add to get -11. We have 2 times 14. No combination of those numbers would multiply to get +28 and add to get -11. 4 goes into 28. 4 times 7 is equal to +28. Is there any combination that would add to negative 11? Well, if you add 4 and 7, that gives you positive 11. If we make them both negative, negative 4 times negative 7 is positive 28. And when you add them together, you get negative 11. So these are the two numbers we're going to use for our factored form, x minus 4 and x minus 7. Again, you can multiply those factors out to make sure that x minus 4 times x minus 7 does in fact equal x squared minus 11x plus 28. Now that it's in factored form, we will set the factors equal to 0 individually and solve to get our solutions for our equation. The first equation, I'll add 4 on both sides to get my solution of 4. And on the right side, I'll add 7 on both sides to get my second solution of 7. What I'm going to ask you guys to do is try number 2 and 4 on your own. Pause the video, go ahead and play it to check. Here are our answers for number 2 and 4. For number 2, we wanted to find two numbers that multiply to get positive 18 and add to get negative 9. Negative 3 times negative 6 is positive 18, and when you add them, you get negative 9. So our factors are x minus 3 times x minus 6. Set them equal to 0, and when you solve, we get the solutions 3 and 6. Last one, number 4, we're looking for two numbers that have a product of negative 20 and a sum of positive 8. We know 10 times negative 2 is negative 20, and when you add them, you get 8. Our factors are x plus 10 times x minus 2. Set them equal to 0 to get our solutions negative 10 times 2. Our last section here is when we have no GCF, and we have 3 terms. However, the difference between this section and last section is that the a value of this quadratic equation is not going to equal to 1. We need to use a different method similar to last section, but we need to add some steps. What we're going to do is multiply a times c, factor, divide, and slide. For number 1, the steps are the following. Since a is 2, what we're going to want to do is eliminate that somehow. We're going to move it over and multiply it times the c value. So 2 times negative 14 is negative 28, which will leave us with k squared plus 3k minus 28 equals 0. Notice now the a value, the leading coefficient, is now 1, in which we're going to factor this just like we did in the section before. So we're going to have two factors in which the numbers are going to have a product of negative 28 and a sum of 3. What two numbers have a product of negative 28? Well, I know it's 2 times 14. Do any combinations of 2 and 14 give us the sum of 3? No, it doesn't. We can move on to 4 times 7. Does any combination of those numbers lead us to add to negative 3? Well, the numbers have to multiply to negative 28. So one of those numbers have to be negative. We'll make 4 negative. If I add 4 and 7, we're going to get 3, so I know I'm going to use those two numbers. Our factors are k minus 4 and k plus 7 equals 0. We multiplied a times c, we factored. Now what we're going to do is divide the a value. Since we multiplied it, the 2, in step 1, what we now have to do is divide it in this step 3. So what we're going to do is divide the numbers we found by 2, which was the original a value. Since I multiplied it first, I now have to divide it out. We're now going to simplify the fraction if we could. For example, 4 divided by 2 is 2 times 7 divided by 2, we cannot simplify, nor will we write a decimal or a mixed number. What we're going to do after we divide, if we can't, we're going to slide the denominator up to the front. So the second factor, since I can't simplify 7 halves, would be 2k plus 7. As I showed you in the last section, we could always double check to see if this is correct by multiplying. K times 2k is 2k squared. K times 7 is 7k. Negative 2 times 2k is negative 4k. And negative 2 times 7 is negative 14. When we combine the middle terms, we're going to get 2k squared minus 3k minus 14, which is the original equation that we had to begin with, so we know that our factors are correct. Now that we have our factored form of the equation, we're going to set our factors, the expressions being multiplied to each other, equal to 0, and solve for k. The first equation, we'll add 2 to both sides to get our first solution of 2. Our second equation, we will subtract the 7 and divide the 2 to get our second solution of negative 7 halves. As long as the fraction is simplified, we could write our solution as an improper fraction. Let's go ahead and try number 3. Step 1 would be to move the a over and multiply it by negative 3. X squared minus 5x minus 6 equals 0. Now that a is 1 in the resulting equation, we could factor it just as we did in the last section. I need to find 2 numbers that have a product of negative 6 and a sum of negative 5. I know that 3 times 2 is 6. If I have to get negative 6, one of these have to be negative. However, neither combination would add to negative 5. Let's try a different combination of numbers, like 6 times 1. If one of these have to be negative, let's say negative 6, if we add those, does that equal to negative 5? Yes, it does. So we will use the numbers negative 6 and 1. They have a product of negative 6, and they add to get negative 5. So we'll have x minus 6 times x plus 1. And since in step 1 we multiplied by 2, this step we need to now divide those values by 2. We'll simplify the fractions if we can. 6 divided by 2 is 3. And if we can't simplify the fraction, the denominator will go in front. So we have 2x plus 1 equals 0. Now that we have a factored form of our equation, we'll set both factors equal to 0. The factors are the expressions that are being multiplied to each other, and get our solutions of 3 and negative 1/2. What I'm going to ask you to do is try number 2 and 4 on your own. Pause the video. Once you get your answer, play the video to check. Here are your answers for number 2 and 4 on our last section here. Trinomials when a, the leading coefficient out front, is not 1. For number 2, you're going to multiply that coefficient 3 times 10 to get 30. Now that the a is 1, we could factor this as we did in last section. We're finding 2 numbers that have a product of 30 and a sum of 17. That would be 15 and 2. We'll then divide the 3 out. 15 divided by 3 is going to give us 5. And since we can't simplify 2/3, the 3 would go in the front. Our 2 factors will be x plus 5 times 3x plus 2. Set the factors equal to 0 and solve to get negative 5 and negative 2/3 as our answer. In problem number 4, the first step would be to multiply the 15 times the negative 4 to get our negative 60. We'll then factor, finding two numbers that have a product of negative 60 and a sum of 4, which would be negative 2 and 10, and then we'll divide the 15. We're going to simplify the fractions if we could, and if we're still left with a fraction, we'll slide the denominator up to the front. 6/15 could reduce to 2/5, so we'll slide the 5 up to the front to get 5x minus 2. 10/15 could reduce to 2/3. Since it's still a fraction, we'll slide the denominator of 3 up to the front. Lastly, we'll set the two factors equal to 0 to get our solutions 2/5 and negative 2/3.